Okay, so let's get started. I want to talk about two things here. First, we're going to talk about convexity. It's a real simple concept. It's going to go real quick. So let me explain the picture, and I think you'll be able to see it pretty easily. The blue line is what I'll call the price function. So the current yield to maturity and the price are right about here. If yields go up, what happens to prices? If yields go up, then prices go down, right? And the reverse is true. If yields go down, prices go up. And that exact price will follow the blue line there. The red line is the duration approximation. So duration, remember the change in price is equal to minus modified duration times the change in the yield times the original price. That's the first order condition of a Taylor series expansion. So I've taken the first derivative. I'm trying to approximate the formula with the first derivative, all from calculus. If you don't remember that from calculus, no big deal. But all you need to do is look at the picture and say, this is an approximation. And just visually, as long as the yield changes are from right about here to right about here, all through here, the duration approximation and the actual price are pretty close, right? So no big deal. But what happens as we get further out, so let me just kind of draw something like this. Well, if we come down, yields go to, let's go to an extreme here. Yields go to 20%. So if I'm 20%, that matches up with a price of about 500. So what duration would tell me, hey, you've moved from just under 10% to 20. You're down from 1500 to 500. But in reality, you would have the change would be where the green line is. Yield about 20% would be a price just under 1,000. All right, so you're off a little bit. Convexity is the curvature of that blue line. So the convexity measures the curvature of the blue line. And just remember, this, well, I get it's all one take today. I'm not redoing this. This is concave. Looks like a cave. This is convex. The opposite. Remember that from high school math. So this line is convex, and the amount of curvature is a convexity. So let me draw a kind of crude drawing here. The purple line is more convex because it has a greater curvature. Now if you look at that and think, well, would I rather have a bond that has a price function like the purple or the blue line? And the answer is the purple. If yields go up, prices go down, but they don't go down as much on the purple line. If yields go up, if yields go down, prices go up, and they go up more on the purple line. So the simple thing about convexity, bottom line, convexity, good. And here's the exact equation for it, for the change in price. With Taylor series expansion, I want to go to the second derivative. So convexity is the second derivative of price, just like duration is the first derivative of price. So go out one more. Oh, by the way, the formula for convexity is a footnote in your book. It's a long, nasty, cumbersome formula. I'm not going to have you work it out. You can all do it. It's just tedious. And tedious enough to do the duration. I won't torture you anymore. So if I'm doing that Taylor series expansion, it's plus 1/2 convexity times the change in yield squared. Now, let me tell you this. Convexity is always a positive number. Knowing that convexity is always a positive number, then the more convexity, the better, right? Because it makes a positive change in price. Because the yield squared is always going to be a positive number. 1/2, a constant, obviously, is a positive number. So that's it. When I am a portfolio manager, bond manager, all else being equal, I would rather have bonds with greater convexity rather than less. Of course, I'll have to pay with that because markets are efficient. Okay, so I'm going to pause right there, and then we're going to go into immunization. Okay, a little history lesson. Ignore this for now. Duration originally was developed by a guy named Frederick Macaulay, and it's for insurance companies. The insurance companies sold something called a GIC, a Guaranteed Investment Contract. So let me give you an example. If you had a 5-year 8% GIC, that means, and for let's do $1,000. It could be $1 million or whatever. So a client would give you $1,000 today, and you would tell them, okay, we'll pay you 8% over 5 years, which means we will pay you $1,469.32.8 5 years from today. So it's just one payment today, and in return you get one lump sum in the future. This works like a zero coupon bond. So we know the duration of anything that's a zero coupon bond is equal to its maturity. So the duration of a zero coupon bond is its maturity. A GIC is a zero coupon instrument. This one has a duration of, a maturity of 5 years, therefore has a duration of 5 years. The question for the insurance company is what to do with this $1,000. The customer gives you the $1,000. You got to be able to pay them back $1,469.32 5 years from today. We're going to invest in bonds because bonds are relatively safe from a default risk standpoint. And the insurance companies will choose to be in investment grade bonds or treasuries. They'll make that decision. We're worried today about interest rate risk because duration is a measure of interest rate sensitivity. So first I'm going to look at bond A, and you have on D2L a spreadsheet called Immunize, and that spreadsheet hopefully will be self-explanatory, or not completely, but hopefully you'll be able to follow what I do with it from this example. I just cut and paste straight from there. And it says this: bond A has 5 years to maturity. It pays an 8% coupon. And by the way, the yield to maturity for everything right now, we're saying everything's equal. The yield to maturity for everything is currently 8%. Alright, so let's assume that those yields stay exactly the same. What will the cash flows look like? Well, here's exactly what happens. I start out today, by the way, this is a zero. I start with $0 in my account today. And that's at 8%, so 8% of 0 is 0. And at the end of the year, I get that $80 coupon payment. I keep this all in one big account. The $80 coupon payment, at the end of the year, I invested 8%. It pays me $6.40. And then I get $80 for the second coupon payment, and that totals $166.40. I take the $166.40, I invest it at 8%. That yields $13.31. So the $166.40 plus the $13.31 plus the new $80 gives me $259.71. I invest at $259.71 at 8%. Gives me $20.78. Then I get another $80. I get that totals $360. $360 is invested at 8%. I get $28 in interest. So my $360 plus my $28 plus my last payment of $1,080 is exactly $1,469.328, and I pay the guy exactly what I owe him. Of course, the insurance company would take a fee, but this is assuming we do it for no fee. Okay, but my big assumption was the interest rates stayed the same. What happens if interest rates don't stay the same? So in this case, let's say that the reinvestment rates immediately dropped and all of these became 7%. So just think through what would happen. The spreadsheet has the exact numbers. I don't want you to think about the exact numbers too much. 7 times 8 is 56, so this would be, instead of $6.40, $5.60. As we go through here, each one of these numbers is just going to be smaller. That's all I want you to know. It's just going to be smaller. If we go through all the math, this turns out to be 1460.06. So if interest rates drop, I'll lose. I owe the guy $14.69. I'm bankrupt. All right. But what happens if interest rates don't drop? If interest rates rise, instead of these being 8% or 7%, now they're all 9%. If it's 9%, that's not $560. That's 9 times 8 is $7.20, right? And all these, rather than being smaller, they're all larger. So it's not 1460, it's 1478.77. Now I make money. So essentially what I've done here is I've made a bet on interest rates. If interest rates drop, I'm out of luck. If interest rates go up, then I win. Okay, pause right there. Okay, so now what we're looking at is bond B. Bond B has 6 years to maturity, 8% coupon, and we're assuming interest rates are, yield to maturity is currently 8%. So we have 3 scenarios, the 8% scenario, the 7% scenario, and the 9% scenario. So let's look and see what happens in each one of them. Alright, so this is what we've gone through before, but there's one difference. I have a 6-year bond, so at the end of 5 years, what's the price of that bond? The price of any financial asset is equal to the present value of the expected future cash flows. So the price in year 5 of the bond is the cash flow in year 6 divided by 1 plus Y, or 1 plus the yield to maturity. The cash flow in year 6 is $1,080. In this first scenario right here, the yield to maturity is 1.08. It comes out to be $1,000. So as we go through here, we hit this exactly, right on the button, right on the nose. Now, well, what happens if interest rates go down to 7%? Well, we know the reinvestment rate, what we did before, reinvestment is down. All these numbers are all lower than these numbers because I'm reinvesting at a lower rate. However, the price in year 5, it's a 6-year bond again, so at the end of year 5 it's got one more payment. It comes next year, it's $1,080, and divide that by 1.07 because rates have dropped to 7%. I can sell that bond for $1,009.35. The numbers are not exact here, and I'll explain why they're not exact in just a minute. But see this $9.35 increase in the price of the bond? That corresponds to a $9.35 almost drop in the reinvestment amount. So this number, 1469.40, is really close, just a few pennies off. So there are two things that go on. There's a reinvestment effect and there's a price effect. Those things are always an opposite. If rates go down, my reinvestment is lower, but my price when I go to sell the bond is up. And the reverse is true. Now let's look at this last one here. If rates go up, that's good news. The reinvestment effect has a positive, right? All these numbers are larger because I'm investing the cash flows at 9%. Hey, but what happened with the price of the bond? The price of the bond at year 5 is equal to the cash flow the next year in year 6 divided by 1.9%, which is 990.83, which is a drop of $9.17. So the price effect was negative. But look, the 1469.60, I needed to get to this number. I do it in both cases here. So how did I know if I chose bond B, it really doesn't matter what happens to interest rates. It's a few pennies, but it's not a big deal. If I chose bond A, I lost by several dollars. So what's going on? What we want to look for is not the maturity, but the duration. The duration of bond A is equal to, let me look that number up real quick. Okay, the duration of bond A is equal to 4.3121. The duration of bond B is equal to 4.9927. Okay, what you need to have, let me move this just a little bit out of the way here. If you have the duration of your assets equal to the duration of your liabilities, then you are immunized. This implies that you are immunized. So the duration of my assets in bond B was 4.9927. The duration of my liabilities, which is the GIC, was 5. So I'm not perfectly immunized, and look, the cash flows are not perfect. Had it been, however, that this was exactly 5, I would have been perfectly immunized. So what you want to do if you want to take no interest rate risk and you have some liabilities, then you get the bond portfolio of your assets to match that duration exactly. Then you don't care if interest rates go up or down, because the effect is exactly the same for both your assets or your liabilities. Let me draw a picture here. So here is our bond, 3, 4. This is our 6-year bond. It's going to make payments of 80, 80, 80, 80, 80, 1080. What you want to think about is if these were weights, and not the $80, but actually the present value. So if I'm dividing by 1.08, 1.08 squared, and on like that, and if those were weights on a seesaw rather than cash flows, the duration is a weighted average life. That would come right under 5, 4.9927, and this would say there's just as much weight on this side as there's that. It would balance the seesaw. So in the application for us, it says the reinvestment effect exactly offsets the price effect at duration. So these effects are always opposite, but they're equal in magnitude if your time horizon is equal to the duration. So what you want to do is, for that bond portfolio, you want to match the duration of assets and liabilities, because whatever that duration is, that's when the reinvestment effect and the price effect, which are always opposite in direction, are exactly the same in magnitude. Here's the one flaw, the one realistic flaw. What happens to duration over time? So we're starting here at time 0, and we're pretty close to being perfectly immunized at 4.9927. But as soon as some time goes by, so we're at 6 months, what's happened to the duration of this bond? It's shorter. What's happened to the duration of the GIC, the liability? It's shorter. So duration changes with time and with yield to maturity, so you can never be perfectly hedged. You have to constantly rebalance. And that decision to rebalance is going to be one of how much it costs you to rebalance versus how much you benefit from reducing the risk. So that's pretty much it for immunization. I'll try to get you some problems to work later on.